Hey guys, welcome to our next lecture. We are going to continue first order differential equation, and in this lecture we are going to talk about separable differential equations. So this is our section 2 and we are going to talk about separable ODEs. So first, we should know the general form of separable ODEs. So separable ODEs look like dy over dx equal to some function gx times hy. And then if you divide by hy, we'll get 1 over hy dy over dx equal to gx. Which you can also say, okay, fy dy over dx is equal to gx. Sorry, I should say fy, not fx, where our fy is equal to 1 over hy. So as the name suggests, the definition of separable equation is simple. That is, we can separate x and y terms on opposite sides of equal sign. We can put all the y terms on one side and all the x terms to the opposite side, to the other side. Then that equation is called separable differential equation. And solving the separable differential equation is super easy. What we are going to do is, we will separate and then we will integrate. Integrate both sides with respect to the independent variable. So we will have integration fy dy equal to integral gy dx. So the procedure to solve separable differential equation is super easy, and we say it's we separate and integrate. That's all. That's all we are going to do. Separate and integrate. Okay, let's look at some examples. So our first example. Y prime plus y square sin x equal to 0. So once we look first at this ODE, we try to see, okay, if this is separable or not. So we put y square sin x to the other side and we divide by y square. So 1 over y square, y prime we can write as dy over dx equal to negative sin x, which means integrating 1 over y square. If y square is in denominator and we want to bring it in numerator, we change the sign of power. Dy is equal to integral negative sin x dx. Okay. I hope you all remember the power rule of integration. Integral of x power n dx is equal to, we increase the power by 1 and we divide by the same power. Whenever you are dealing with indefinite integral, never forget to put a constant of integration. Okay. So here we want to find out the integral of negative y square dy. So we will increase the power by 1. Negative 2 plus 1 is negative 1 divided by the same power. So it's equal to negative 1 over y. This is indefinite integral, but I am not putting the constant of integration. I'll show you why. So in the left hand side we have 1 over y equals negative, this negative sign, and the derivative of sine x is cosine x, so negative cosine x, plus constant of integration. So if you are dealing with equations, you can just put constant of integration to one side, because suppose you put constant of integration to both sides, C1 for left hand side and C2 for right hand side, it's same as saying, so we are setting negative negative is positive x, and we are setting our C equal to C2 minus C1. So if you are dealing with equations, putting the constant of integration to one side is sufficient. So our solution is y equal to, don't forget this negative sign, we had a negative sign over here, so y is equal to negative 1 over cosine x plus c. This is our final solution. Super easy, right? Let's see one more example. So our next example, we will see a differential equation with some initial conditions, which is initial value problem. We call it initial value problem. So suppose y prime is equal to 2x divided by 1 plus 2y, and the value of y at x equal to 2 is 0. Okay. So we can easily separate the y terms to one side and the x terms to the other side. So this is separable equation. If we have a separable equation, we just need to integrate both sides. So 1 plus 2y dy integral is same as integral 2x dx. Integration of 1 is y times this 2. Integral of y is, we increase the power by 1 and we divide by the same power, equal to 2 times integral of x, which is we increase the power by 1 and we divide by the same power. And don't forget the constant of integration. Now this 2 will cancel out and we will get y plus y square is equal to x square plus constant of integration. This is our solution, but we have the initial condition. Don't forget to plug in the initial condition. We have that value of y when x is 2 is equal to 0. So if we plug in this condition, so 0 plus 0 square is equal to 2 square plus c. 0 equal to 4 plus c. If we subtract 4 both sides, we will get our c is equal to 4. We plug in back the value of c. So our solution is y plus y square equal to x square minus 4. This is our final solution. So we will stop here for this lecture, and I will see you in the next class in our next video. Till then, take care, practice some more problems about separable equations, and bye bye.